Welcome to this technical deep dive into SOCKS5 Proxy implementation using SSH tunneling. This video is for network engineers and IT professionals looking to understand practical applications of secure network routing. SOCKS5 Proxies enable secure traffic routing through encrypted SSH tunnels. Today we'll walk through a practical implementation, showing you how to set it up and why it's so effective. By the end of this video, you'll have a clear understanding of how to enhance your network security and bypass restrictions. So what exactly is a SOCKS5 proxy? Unlike HTTP proxies, SOCKS5 is a versatile protocol that routes network packets between a client and server. It operates at a lower level of the OSI model, making it more flexible and robust. This flexibility is key to its security benefits. By supporting both TCP and UDP connections, SOCKS5 can handle a wider range of applications, from web browsing to gaming, all while maintaining a secure connection. Its neutrality means it doesn't interpret network protocols, simply forwarding data, which adds to its security by avoiding common proxy vulnerabilities. Now let's look at the technical flow of how we'll implement this. We'll be setting up a scenario where a Windows virtual machine communicates through a SOCKS5 proxy on a host machine, which then tunnels traffic over SSH to a remote server, finally reaching the internet. Our journey begins with the Windows VM. It's configured to direct all its internet traffic to the host machine, specifically to a designated port, in our example, 10.0.2.2, 8888. This initial connection forms the first leg of our secure tunnel. From the host, an SSH Dynamic Port Forwarding command creates the SOCKS5 proxy. This uses the -d flag to establish an encrypted tunnel to a remote server, like 203.0.113.10. All traffic from the VM now flows through this secure SSH tunnel. This setup is crucial because it encrypts all traffic. Once inside the SSH tunnel, your data is secure from eavesdropping and inspection. This process effectively bypasses network restrictions, making your activities appear as simple SSH traffic. Let's move on to the practical implementation. We'll walk through the exact commands and configurations you need to set this up yourself. Pay close attention, as these steps are crucial for a successful deployment. First, the SSH tunnel setup. Open your terminal and use the SSHD command, specifying the local port you want to use for the proxy and the remote server's credentials. This command creates the dynamic port forwarding that acts as your SOCKS5 proxy. Next, we configure the Windows proxy settings using registry commands. These commands direct all internet traffic from the Windows VM to the local host's SOCKS5 proxy port. We'll also set bypass rules for local addresses. So why is this method so effective? The magic lies in how corporate firewalls and network monitoring tools perceive your traffic. When you use an SSH tunnel, corporate firewalls only see encrypted SSH connections. They cannot inspect the content of your web requests because all the traffic is encapsulated and encrypted within the SSH tunnel. It simply looks like standard SSH communication. This means that all your web requests and other network activities appear as benign SSH traffic. The actual destinations of your web requests are completely masked. This is a powerful technique for maintaining privacy and bypassing deep packet inspection. Let's summarize some key technical points to reinforce your understanding of this powerful solution. Firstly, SOCKS5 supports both TCP and UDP protocols, which is a significant advantage over HTTP proxies that are typically limited to TCP. This versatility allows SOCKS5 to handle a much broader range of network applications, making it incredibly flexible. Secondly, the SSHD flag is critical. It creates dynamic port forwarding, effectively setting up a SOCKS5 proxy on your local machine. This dynamic aspect means you don't need to specify individual remote ports for each service, simplifying configuration. Next, understanding VM NAT network routing is essential for this setup. The Windows VM is configured to use the host's IP address as its gateway, ensuring all its traffic is routed through the host, where the SOCKS5 proxy is established. Finally, the inherent traffic encryption provided by SSH prevents inspection. Your data remains private and secure throughout the tunnel, making it an excellent method for bypassing network restrictions and enhancing your online privacy. That wraps up our detailed look at SOCKS5 proxy implementation using SSH tunneling. We've covered everything from the fundamental concepts of SOCKS5 to its practical implementation. You now know how to set up an SSH tunnel for dynamic port forwarding and configure your Windows client to use it, ensuring your traffic is encrypted and routed securely. This knowledge is invaluable for network engineers and anyone looking to enhance their network security and flexibility. By leveraging these techniques, you can ensure your network traffic remains private and bypass many common network restrictions. Thank you for watching.